Hello, we're now in lesson 10-2. We're going to be exploring equivalent ratios. We'll start off with the launch problem. Just try your very hardest and we'll go over the solution when you're finished.
A website sells song downloads for $2 each and movie downloads for $5 each. Your friend buys the same number of movies as songs. If he spends $20 on movies, how much does he spend on songs? Use the multiplication table to show the solution.
Your friend would be buying 4 songs and 4 movies, so your friend would spend $8 on songs and $20 on movies. Being able to use the multiplication chart, you knew that you had to spend $20 for movie downloads. And so you would move over to the 2 because that's how much each movie was, and you would see that you would spend $8. This key concept is going to be able to explain our launch problem answer a little bit more clearly.
Equivalent ratios are ratios that express the same relationship. You can find equivalent ratios in a multiplication table. You can use rows and columns in a multiplication table to find equivalent ratios. The terms of the ratio 10 to 15 are in the 5s column in the multiplication table.
Meaning 10 to 15 is going to be equivalent to 8 to 12, 6 to 9, 4 to 6, 2 to 3, and also equivalent to 12 to 18. 14 to 21, 16 to 24, 18 to 27. We'll learn that now with lesser terms, greater terms, and multiples.
Pairs of numbers to the left of the terms of the original ratio form equivalent ratios with lesser terms. The ratios 8 to 12, 6 to 9, 4 to 6, and 2 to 3 are equivalent to 10 to 15.
So you look at this as a ratio, kind of like a fraction is set up, top number over bottom number, and knowing that all of these ratios, because they're in the same row, are going to be equivalent. They're the lesser terms because those numbers are less than 10 and 15.
Pairs of numbers to the right of the terms of the original ratio form equivalent ratios with greater terms. The ratios 12 to 18, 14 to 21, 16 to 24, and 18 to 27 are equivalent to 10 to 15.
And again, these are our greater terms because these numbers are greater than 10 and 15, but they are still equivalent.
All of the corresponding multiples in 2 rows or columns form equivalent ratios. Multiplying 2 and 3 by 5 gives the original ratio 10 to 15.
So we get that from up here. Since these are in the ones column, 2 times 3, and we're multiplying it by 5 to get to this 5 columns, that's why it's equivalent. If we did 2 over 3 times 2, 2 times 2 is 4. 2 times 3 is 6. That's what it's explaining when we're talking about multiples. Part 1.
Use the multiplication table to find ratios equivalent to 12 to 16. Find 3 ratios with lesser terms and 3 ratios with greater terms.
What I want to do is I want to find where 12 and 16 meet up. So I see 12 and 16 right here, so I'm going to circle them. And it says find 3 ratios with lesser terms and 3 ratios with greater terms. So my 3 ratios with lesser terms are going to be 9 to 12, 6 to 8, 3 to 4. Can you tell me 3 ratios with greater terms? On here, there's 4 possible ones that you could have showed me. 15 to 20, 18 to 24, 21 to 28, 24 to 32, those are all possible solutions. You could have kept going, but according to our multiplication chart, we ran out of numbers. So I'm okay if you just used 3 of these 4. Now we're moving to the Got It problem for part 1.
Use the multiplication table to find ratios equivalent to 24 to 28. Find one ratio with lower terms and one ratio with greater terms.
Here are some possible solutions. The correct answer is 12 to 14 and 30 to 35. So again, we wanted to find 24 to 28. So here's 24. Here's 28. Even though they're kind of sideways compared to what we were looking at before. So before we were looking at numbers that were on top of each other. These numbers are on side of each other. These terms right here are going to be my ratios with lesser values. And then these ratios right here are going to be the ones with greater terms. So 30 to 35 is the example that the problem gave us, but you also have 36 to 42, 42 to 49, 48 to 36, or 56. Moving on to part 2.
Complete the equivalent ratios.
What we want to do is be able to see numbers that go within our multiplication chart. So what you could do is you could fill in these numbers first. So 5 times 4 is 20. 6 times 5 is 30. 7 times 5 is 35. And you can fill in all the numbers. Or another way we can look at it is only fill in the numbers that we need. So 21 and 24. I need to find where 21 and 24 fall. 8 times 3 is 24. And I also know that 3 times 7 is 21. So I will add this number in. And I know that any of these are going to be equivalent ratios because they fall within the same rows. So my next number is 49, so I got to match up 21 and 49, so that's right there. And now I know that I need to find this bottom number because this one's going to match up to my 24. It's like sliding it over. So in order to get this number, I need to do 8 times 7. 8 times 7 is 56. And 56 is going to be my answer. So it really is just finding the missing pieces in our multiplication chart. The next one we're looking at is 15 to 21, which we can see right here that those are in the same column. There's 15 and 21. Even though there's this empty column between it, that's okay. As long as they're lined up, it will work. So 15 to 21, we're going to slide this over, and we see here's 49. So the second number matches with our second number of the first ratio, 21 and 49. Up here, 15 is equivalent to 35. So our ratio of 15 to 21 is equivalent to 35 to 49. Can you solve the last one on your own? All right, so we see 25 to 35 right here. 25, 35. We want to slide it down so that our lesser terms have 15 in it, and then we match it up down here. So 21 is going to be the answer to make our equivalent ratios. Here's our part 2 got it problem.
Complete the equivalent ratios.
The correct answer is 14. We need to find 18 and 36. I know if I completed my table, 9 times 4 is 36, and so I would see 18 here, 36 over here, and I would want to move up until I got to 28 and then match that on this side as well. Move up. So 2 times 7 is 14 and would complete this box. Moving on to our last part.
In one class, 3 of every 8 students have braces. There are 32 students in the class. How many of the students have braces?
So 3 to 8 students have braces. And if there are 32 students in the class, we know that's our total. And so we want to know how many are going to have braces. What I could do is I could build a multiplication chart, or I can just know that I'm trying to find equivalent fractions. Really, finding equivalent ratios, they're very similar with each other. So I first wrote this out as a ratio like we've been seeing it with the colon. But what I could have done is I could have written it out like a fraction as well. And this is still one way that you can write a ratio. So we want these two things to equal. 3 to 8 is going to equal something to 32. So we need to figure out what times 8 can get me to 32. And we should know that 8 times 4 is 32. So in order to get this missing number, we would have to do 3 times 4. 3 times 4 is 12, which means there are 12 students who have braces in the class of 32. Here's our last got it problem.
In the same class of 32 students, 1 of every 4 students wears glasses. How many of the students wear glasses?
The correct answer is 8. You can use multiplication charts. Know that I have the multiplication chart in the front of my classroom when you're coming in and doing that digits work in class. If you don't have a multiplication chart at home, talk to me and we can get you one, because it should really help you out if you are a visual learner. Otherwise, you can set it up kind of like a fraction and find equivalent fractions, but finding equivalent fractions is very, very similar, almost the same as finding equivalent ratios. That's all I got for you for this lesson. Be ready to come to class, ready to work hard.